this video we'll be looking at the equations of motion and how to prove them really. So let's just take a velocity time graph and so velocity is on the y-axis as it's usually known as, and t is the x. So let's establish some points here. So this point on the left is the original or the initial velocity, and this one's the final velocity. Okay. And this is the bottom half of the triangle is actually the length of time that this increase in velocity occurs over. So acceleration equals v minus u over t. That's the gradient of this, I suppose, and so v minus u equals at. Okay, and therefore v equals u plus at. Alright, let's look at two more graphs now. Two more velocity time graphs, I should say. So let's have the same type of points here, and we're gonna basically, the displacement or the distance is actually the area under the graph. So let's just say that let's find the area of a trapezium. So in this case it's 1/2 u plus v multiplied by the length of time it occurs over, which is t. Okay, and for this one it can be seen as a triangle and a rectangle. So S can equal ut, that's the rectangle, multiplied by, oh sorry, not multiplied by, plus half at squared. So that's the area of the triangle. However, u is v minus u, which is actually multiplied here, and v minus u is equivalent to at, so you can replace the at times t with an at squared. So using these results, we can find quantities of the motions of objects. So let's try and do that. So let's suppose that there's a football kicked at 15 meters per second. That looks a bit like a 13, that's meant to be a 5, at 40 degrees to the horizontal, and we want to find where the ball lands. So we can predict its trajectory to be a bit like this, and then there's a point x here. Okay, so we're going to use the equation S equals ut plus 1/2 at squared. Now we're going to do this in vector format. So S can be x, that's an unknown distance, and the height is 0 because this is where it lands on the ground again. The initial velocity is just, we're going to take components of this 15 meters per second, so it's going to be 15 cos of 40 and 15 sine of 40 times by t, and plus, so as we're resolving upwards in this case, acceleration due to gravity is going to be negative t squared, and then what we can do here is resolve upwards. Okay, so 0 equals 15 sine 40t plus, actually, minus 4.9 t squared. T equals 15 sine 40, because you can divide by t, because the other t is just going to be 0. divided by 4.9. Alright, and t equals 1.97. I already calculated that on the calculator. Sorry to spoil the results. But what we do here is to find x, we just... Sorry, that's supposed to be an equals up there actually. We just resolve horizontally. So let's do that. So x equals 15 cos 40 times by 1.97, and then this top bit here actually equals 0. This is due to the fact that there is no horizontal component of acceleration, so therefore x equals, let's just calculate this, alright, so x equals 22.6 meters to 3 significant figures. Always include your units there.